Hello, everyone, and thank you all for joining us for our June installment of Agrochem's monthly webinar series. Today's presentation focuses on a crucial aspect of any dairy operation, which is the care and proper cleaning practices for calves and calf equipment. Today, we are joined by our resident calf care experts, Agrochem's own Ginger Bramall and Emma Swires. Today's presentation will be followed by a Q&A session, so please feel free to put your questions in the meeting chat, and we'll be answering them at the end of the session. So without further ado, let's welcome our presenters and begin today's discussion.
Thank you, Brent. So if we ask any dairyman what is the main issue they have with their calves, what we hear is scours. Scours is the main issue. Well, scours is just a nicer word for diarrhea, is what I think. So scours is something we would typically see in very young calves, so ages probably between 7 to 14 days, primarily due to their limited immunity. So our scours symptoms that we're typically seeing when you notice a calf like this, you're going to see watery, bloody, milky, mucousy feces. The calf is going to be extremely dehydrated, so they're going to have the effects with looking weak, with swollen eyes, and also in this time, just because of what's going on internally, they're going to have very poor nutrient absorption. And then you may even notice some swollen or inflamed joints at this time as well. Why are the first 2 weeks of a calf's life so incredibly critical? Because when a calf is born, they're actually like us, they're monogastric. We know cows and bovine in general have a 4-chambered stomach with the rumen doing most of the digesting. But when the calves are born, they're monogastric. Most everything is coming down through into the abomasum and then passing into the intestines that way. Well, pretty much from the tongue all the way down through, their system is leaving gaps in their whole GI tract in order to allow antibodies from the colostrum to go through. So the colostrum, obviously, we know is really only for the first 24 hours it's allowing through, but it takes up to a week before, or to 10 days before these gaps all the way through are completely closed. So in that time, you're going to get pathogens that can easily go through these gaps. And that's why calves are so incredibly susceptible to diseases during this time. So after those 7 to 10 days, when those gaps are closed, you're going to have much stronger pathogen defenses in the calves. So you're going to have a much lower rate. So, but the first 2 weeks or 10 days are incredibly critical for a calf. So let's talk about causes of scours, which could be considered as non-infectious, so not looking at the pathogens. So one big thing is actually the health of the cow herself prior to calving. So just her body score, because that has a lot to do with then the quality of colostrum she's giving off. Now I know we give a lot of calves colostrum directly, but having an easier birth, having a healthier cow does affect the calf as well prior to. Poor management. So of the person feeding the calf, specifically the colostrum. So it would be the quantity of colostrum that they're getting, perhaps the quality of it as well, and getting it in a very timely manner. The last one being quality and cleanliness of calving facilities. So temperatures and stuff, are they very dirty? Are they very wet? These are a lot of issues that cause a lot of stress on the newborn calf. So the main infectious agents that we look at are bacteria, virus, protozoans, and molds. So our main bacteria, we see E. coli, salmonella, clostridium, virus, rotavirus, coronavirus, BVD. Our protozoans, Cryptosporidium parvum is the main one, and coccidiosis. And then we have additional molds as well that we look at. So we want to talk about the economic cost of what a scouring calf, the effects of a scouring calf. So, we're thinking about calves being born, especially heifer calves. We have to think about the fact that the heifer calf is born with all the eggs she's ever going to have. Okay, so then not only does she have all the eggs she's going to have, also all of her progeny is within that, and their progeny's progeny as well. So one thing to consider too is so with the future life. So our scouring calf, obvious thing is that we can have an increased mortality. They just die in their rearing period. They're a weaker calf. We lose it. Well, when a calf dies, we've direct loss of value for what we were hoping to get out of her. All the direct future breeding and potential is gone. So a lot of our customers are very specific about their breedings with their AI programs, with their crossing for what the progeny will be, with their production, with their other things we look for. And well, that's gone. We're never going to know. Additional costs, the direct cost of treatment. So if you have to have any vet work done with your calves, any medication you choose to give them, electrolytes, the hydration, a lot of it's mostly the labor, the fact that your babies are sick and they need a lot of attention now. So that's a lot of time and labor and cost in that. The increased susceptibility to other diseases. According to a study, they're 18 times more likely to develop pneumonia if they were sick within those first couple weeks with scours. So then you have the additional cost of medication and with labor. And then your additional, so lower growth rate. If they are sick in their first couple weeks, they're going to have decreased daily gains for a longer period of time. So that increases your cost of finishing, your delayed time for market, and your less uniform calf crop. So in the way that this calf is delayed, whereas all the other ones born are roughly the same day, she's a couple weeks behind. All right. By doing that, you have a delayed breeding maturity. Okay. So she's not going to be able to hold a pregnancy, or you're not even going to be able to come into heat for a little bit longer. So that's going to be fewer calves during a cow's life with a higher replacement cost. So overall, but then just the fact that she was sick to begin with is the fact that she's passing on issues all the way through future progeny. So scours treatments. All right, there wasn't good enough prevention. Let's do scours treatments. What can we do? Well, our options are hydration. Okay, we need to keep her levels up to avoid dehydration, because that will be the big killer. All right, so we can do that orally or intravenous. Both are a lot of work. Electrolytes, keeping salts, minerals high enough in the body while she's fighting this off for her to be able to get through. And prayer. It sounds like an absolute joke, but that's the point being, is prevention is the only key, because there isn't a lot of treatments whatsoever. So once they have it, you just have to try and get them through it. So how do we prevent scours? So cow health is a main one, as we mentioned before. So cow health being, we want adequate nutrition for your cows. For your dry off period, you want to make sure those cows are calm and comfortable and fed well with adequate nutrition, have a good body score, because that affects their calf that's coming out as well. All right, our colostrum, we want to make sure we're getting 4 quarts of quality colostrum within 2 hours of birth, so we can have that time for it to pass, those antibodies to pass through those gaps, to give our calves the best immunity they can possibly get. Their calving pen, we would like a clean, dry, warm calving pen. We want to make sure that they're born well, right? That they're not picking up pathogens as soon as they hit the ground. Our calf facilities, we need effective cleaning procedures for our pens, our buckets, our bottles, our waters, anything that the calf touches. And we mean not just visibly clean, we have to do some sanitation steps to be able to clean the bugs and the microorganisms that are in biofilms that are actually the calves can lick. All right, so calf nutrition also. We want to make sure we're getting consistent quality and quantity, whether it's milk replacers, milk itself. We need to make sure they're getting the right amount of food, the right amount of milk specifically, at the right time consistently. And then also for before they're born, there is some options for vaccination of cows, specifically for E. coli is an option some people want to take. So that's how we prevent scours. So how is we at Agrichem, how can we help? So the main thing is the calf facilities. So in terms of cow health, colostrum, calf nutrition, vaccination, we would prefer not to give advice on that as much. There's veterinarians and others who are trained much better, who'd be able to go through that much better. But when it comes to clean calf facilities, an effective cleaning procedure and a measurement of a cleaning procedure, if it's being done well, that's how Agrichem can help. Because as I mentioned, calves are going to lick everything. And we want to make sure what they're licking has the least amount of pathogens as possible.
So moving into how we do that. So looking at when we do that, so buckets, nipples, bottles, tubers, anything that comes into contact with a calf's mouth and is used for daily feeding should be washed after every use. So whether that be 2 times a day, 3 times a day, even 1 time a day, it needs to be cleaned after every single feeding. That way you're not contaminating from one calf to the next, and there's no sharing of germs. For pen panels, flooring, anything to do with the housing, we want to clean that after every group of calves, whether that be 6 to 8 weeks in the wean period. You want to clean out that stuff as soon as that group of calves leaves. You don't want to put a new calf in an old calf's pen. You're just, again, cross-contaminating and suscepting a new calf to anything that old calf left behind. You also want to clean out waters and automatic feeders. We recommend something weekly, but you can also do it when it's visibly dirty, if that does become more of a problematic thing throughout the week. You really want to stay on top of things so you're not suscepting those calves to anything after it's dirty. And then also you have group feeder nipples, which need to be cleaned daily so we don't cross-contaminate as well. So scours prevention is super important in calves, and when you're looking at traditional wash and sanitizing, you have your scrub step, your rinse step, an alkaline step, which is also known as a detergent step, your rinse step, a sanitize, and a dry step. Some typical problems that everyone sees on farms, there's not enough hot water, whether they can't get up to those hot temperatures, whether the employee just physically can't scrub in those super warm temperatures, but you really want to maximize that and get it as warm as possible. Also, some traditional sanitizers can't penetrate through membranes, whether that be microorganisms, bacterias, and biofilms. And some people only wash with chlorine or bleach. I know that there's a lot of farms still out there just using just your typical soap, even sometimes not even chlorinated soap. So really they're not doing anything to break through biofilms or really tough bacteria. So looking into the housing, mobile parts, you want to move those outside. You can pressure wash them because they're in an open environment now. And then you want to foam wash and scrub, and then rinse, and then dry and sanitize prior to new bedding and animals moving in. And mobile parts, ideally you want to remove as much manure as possible. That way you're not suscepting the chemical to any organic load and automatically killing off all the chemical right away. Then you want to rinse, and then you want to sanitize. Ideally, you want a rest period in between animals, but if that's not practical in your operation, then you want a couple hours to get things dry, and then you can move animals in. So looking at things that are being used daily, so feeding equipment, we want to mimic what is happening in milking parlors, mimic those CIP practices. You also want to recognize the materials you're working with, whether that be stainless, whether that be plastic or rubber. All things are different, and you need to know when those pieces of equipment are no longer able to be used. For example, calf buckets are a really good one. Usually we just keep on using them until they're actually broken. However, a lot of those calf buckets are made out of plastic and get scratched quite easily throughout calf's use. And those scratches can harbor a lot of bacteria. So really recognizing when a piece of equipment is unsalvageable, get more in stock, and really change out those pieces of equipment. Also ensure that you're cleaning with something that is clean. So looking at those scrub brushes and making sure that they're not dirty when they're starting to be used in these processes, making sure that they're getting sanitized and also going through the processes and changing out once a month or having a good protocol in place so that you're not using the same brush for over 10 years. I know that seems extreme, but that's also something to look at. So going into the steps one by one. So you have your rinse cycle. Really important step. You want to remove all the organic material found in milk, just so the so when you get to the detergent step, you're not completely deteriorating everything in the detergent. So you want to get approximately 90% of everything off the surfaces when you do the rinse step. And you want to use lukewarm water so that you can remove as much as possible. The detergent step, you want to use as hot as water as you can. If ideally you want to be in the 140 range, but at minimum you want to stay above 120, so you really are breaking down fats. So if you can't achieve that temperature, we do have some other options, but we'll get into that a little bit later. And you also want to be in that 11 to 12 pH. To achieve that, you want to use a chlorinated alkaline. For most of the products, you're going to use 3 to 6 ounces per gallon of water. And just to reiterate, the chlorine is dissolving the protein, and that's why it's pretty essential to use a chlorinated alkaline. And then the alkaline is going to dissolve your fats. And then lastly, in the detergent step, you really want to scrub to fully remove any films. So looking at what kind of products you should be using on things that are used daily, such as your buckets, nipples, bottles, and other mixing equipment, using something like your foaming chlor alkaline manual cleaner, AgriClean 305, AgriClean RTC, which stands for reduced temperature cleaner. So those people that can't achieve 120 or greater degrees, you really want to use AgriClean RTC to try and best remove those fats. For pen separators, pen siding, walls and floors, using Control 885 and foaming chlor-alkaline manual cleaner are really good options for foaming and removing those films on the separators. So the foaming alkaline manual cleaner is something we recommend in the calf equipment cleaning because you do get that foam versus something like your typical AgriClean 305. It's not going to foam as much because it's heavy caustic and it's not meant to be foaming. That way you can physically see what you're scrubbing. So it penetrates soils for effective removal, provides excellent sheeting action for quick and spot-free drying, and used on exterior surfaces of storage vats and processing surfaces. You're going to use this at a 4 to 6 ounce per gallon, and it foams really, really well. Then going into the steps again, there's going to be an optional extra rinse. If you don't want to use as much product in your acid step, you really want to have the optional extra rinse. It prevents that contamination from going from the detergent sink to your acid sink, and then you can use less product, and you're also removing any lingering debris. For this step, you can use lukewarm water. So then going into the acid step, if you are going from that detergent to just your acid step, you really want to get down into that 3 to 2 pH range. So if you do contaminate the water, it stays fairly low. You also want to use some warm water, and the purpose of the acid step is to remove mineral buildup. And it also is to prevent any future bacteria growth. Bacteria grows in neutral, likes to grow in neutral environments. However, it really does not thrive in acidic environments. So we really want to, this is pretty central to the calf equipment side. Then you want to dry things out. Depending on your operation, sometimes you do the sanitize step and then dry. Whatever works best for your operation is what we recommend. If it's not feasible, if it's not going to work to sanitize that 1 to 2 hours that's recommended before you feed, then by all means sanitize before you dry. The sanitize step is pretty essential to remove any microorganisms and biofilms. So then going into that sanitize step, so your goal is to eliminate any microorganisms, like Ginger said, things that you can't see, eliminate those biofilms where the microorganisms live. In the sanitize step, you can soak, spray, foam, and use it in an ambient temperature. Ideally, you should use it 1 to 2 hours, but like I said, if it's not practical on your operation, then as long as it's not getting washed off, it's being effective. And one of the gold standards for the calf cleaning industry is using chlorine dioxide. So another optional or another recommended sanitizer, which doubles as an acid, is OxySan. It's an EPA registered sanitizer. It combines the acid and the sanitize step. So in order to sanitize your calf feeding equipment, you really want to stay over that 125 ppm. That's kind of your minimum of where you should be. To achieve that, you want to use 2 to 3 ounces per 5 gallons of water. And OxySan is a broad spectrum, it gives a broad spectrum kill of gram-positive and gram-negative bacteria. The other great thing about OxySan is that it's very versatile. So you can use it for water treatment, you can fog it to try and eliminate some airborne bacteria. Really just combining those two steps is super helpful to keeping your labor efficient. Another alternative sanitizers are Control 885, which is a quaternary ammonia. And it's an easy concentrate to put into a solution. You're not having 2 parts. It's just the concentrate and water. Depending on the soil load, at minimum, we want to use 2 ounces per gallon of water. But if you're cleaning something super dirty, recommend increasing that concentration. And it also stays stable for a long period of time. So you can use it for a good amount of time without it going bad. It also is odor-free and pH neutral, so it's really easy on your employees' hands, and it's not going to be harsh on their lungs and everything.
So we want to take a little time as we're going through the sanitation step. Emma did a great job of describing the steps of cleaning, what we can visually clean. But then it comes down to the cleaning of the biofilms and the specific microorganisms that are really where the pathogens live. So we created this chart. The benefit being is the comparison components. So on the top left and going down, we have some of our main bugs that we see and fight with our calves. So from E. coli all the way down to crypto, rota, BBD. Then it talks about how biofilm is removed, whether it's good or not, if the product is corrosive, if it can be used with water or disinfectant. And so then on the top column across, we're going across the different types of sanitizers that can be used or have been used. So some that other people use are ozone, hydrogen peroxide, peracetic acid, which is our OxySan, as we mentioned, bleach, chlorine dioxide, quaternary ammonia, our phenols, and then iodophores, so essentially iodine. So as an example with E. coli, you can see going across the top that it's yes for all. So E. coli is fairly easy to kill as long as you're doing a quote unquote sanitation step. So sanitation meaning you're spraying it on there, you're foaming it, you're dunking it, you're not washing it off, okay? But one that we struggle with or have struggled with a lot in our calf health in the past has been our Cryptosporidium parvum, so the third one down. If you go across, what you see is there are only 2 items that actually can kill that. And that would be ozone, which is a very difficult thing to put on a farm, and chlorine dioxide. And if you go down the chlorine dioxide column itself, what you see is it kills all things and is not affected by pH, which is great. It's not unaffected by organics. It's not carcinogen. So really, if you're going down this whole chart, that is your gold standard. But we want to talk a little bit more about crypto and why so many of the other killers have trouble with it. So Cryptosporidium parvum, what that is, it's a protozoan organism. So it's a very tough outer shell, all right, and then it produces oocytes and sporocytes. So when a calf has crypto, it's called Cryptosporidium, and the sporocytes and the oocytes are coming off of that hard single cell protozoan, and they're attacking intestinal cells. So when intestinal cells die, what they do is they atrophy. And when we think about our functional intestines, we have villi. They look like fingers, right? Well, the reason they look like fingers is for surface area for nutrient absorption. So if those start to atrophy and curl up, you lose all your nutrient absorption, right? So then the cow recognizes that she's sick. So what happens? She starts shedding it through feces. She has scours. And then obviously these sporocytes, oocytes are living in the manure, and that gets on things, calves lick it, and then we start it over. So because that's protozoa, that single cell layered organism, that tough outer shell, most other chemicals you would use for a sanitation step can't penetrate that. But what's unique about chlorine dioxide, and we can go to the next slide. What's unique about chlorine dioxide is it diffuses through that shell, and then it actually kills within the mitochondria itself. So it's not affected by shells or different outsides, whereas many of those cleaners and sanitizers, they have to kill the outside. They crush it from the outside. This doesn't do that. So because it doesn't work that way, there isn't really anything that it can't kill, which is why it was killing everything, is because of the way it diffuses through the cell membrane. So it's not affected whether a bug is anaerobic or aerobic, and it can't develop any sort of resistance. So even for any of you who are in the T-tip industry, it's the same thing. Why chlorine dioxide, you need very little of it to be a very powerful broad spectrum killer, because the way it kills everything. So, and we mentioned it's more effective than bleach and chlorine because those have been the traditional uses in the past. So bleach and chlorine, when it comes to crypto, are not going to be very helpful.
So getting into Agrichem's chlorine dioxide cleaner and deodorizer, it is called CD114. The mixing rate is 1 to 1 to 4, which is taking your part A, your part B, and 4 parts of your water. So because it's chlorine dioxide, you have to take 2 parts and mix them together. Otherwise, it won't stay for the long periods of time that we want it to. It does stay active for around 7 days, but we'll get into that later. So when you mix it at the 1 to 1 to 4, you're going to get a ppm around 2200. But there is other ways that you can mix it. And for calf feeding equipment, we want to have that 3 to 6. We're trying to achieve that 3 to 600 ppm for a good kill, which is mixing at a 1 to 1 to 14 or 32. So some of the marketing strengths, obviously, like Ginger said, it's really effective at killing crypto, killing it from the inside out. And it can be sprayed, foamed, fogged. It's really good on calf hutches, floors, walls, buckets, etc. And it holds stable for a couple days after being mixed. And it can be more diluted out to achieve what kind of ppm you're looking for. So at the 1 to 1 to 4, this is just showing you what it starts at and how stable it stays for up to 144 days, or 144 hours, my bad, sorry. At 2200 ppm, it starts, and then by 7 days, it actually is, that's where its half-life starts. So looking at applications for calf water treatment, we really need a low range of ppm. 1 to 3 is sufficient in terms of keeping the water treated. Then you have your bottles, nipples, buckets, and mixing equipment. We want to be over 300 ppm. And then in the environment, without livestock present, we want to stay over 1,000 ppm. However, when there is animals present, we want to stay under 100. We really don't want to suscept those animals and their lungs to any harsh chemicals. Then with agrichem, we can sometimes provide a pump on the farm to be able to mix the CD114, and this pump is called an AccuMax. So without any tips and it's a Venturi style, so you have tips inside and it's water driven. And without any tips, you're going to achieve that 1 to 1 to 4 and be in that 2000 range. With the white tip provided by the AccuMax pump, you're going to achieve the 1 to 1 to 14, which will give you around a 600 ppm titration. And then at that 1 to 1 to 32, you're going to have the blue tip, and that will achieve around 300 ppm. So while we're all saying this, it's really important that we're measuring how effective our cleaning processes are. And how we can do this is by measuring with an ATP meter, which is also known as a luminometer, which measures the presence of ATP, also known as adenosine triphosphate. And this meter actually measures in relative light units, which is also known as RLU. So the more intense light there is, the more ATP is found in whatever you have swapped. The goal is to have as little bacteria on surfaces as possible. In the food industry, they use these all the time, and they're looking for less than 50 RLU. In the farm industry, we have about 100 RLU. We want to see 100 or less RLU, but you also want to ensure a good sample and taking these over time so that you're not just coming into a dairy and swabbing something once and then saying, wow, this is really high, but maybe it was just a bucket that had been sitting there for over 3 months. So really measuring these things over time and keeping a good track of it can help a farm make good management decisions and how their protocols are working. So how to use the ATP meter? You turn it on, swab a desired area in a crisscross manner, and you want to be in like a little 1-inch square. You don't want to touch the swab. You snap the top and squeeze all the liquid in, and then press OK after the swab is inserted in the ATP meter. And then you just wait for the result. Also, in agrichem, we have made these protocol sheets, which are super helpful in terms of if you go onto a farm and are putting in all the products, you want the farm to be using it in the right amounts. So having this protocol sheet so any employee can walk in there and do that job. So it has all the steps on there, and we can give those to you if you need them.
So in our conclusions from the webinar today, before we open up for questions, we just want to remind you that scours is the most costly health issue for calves. because when they're born, they have no immunity. All right. It costs in time and input costs, reduced production, reduced possibilities for that calf and for her future progeny. The fact is, when they have scours, there's almost no treatment, right? It's just water and electrolytes. All right. So the key is prevention. So the factors that we at Agrichem can help control is actually working with you and with farms for a cleaning protocol. So we want to set the farm up with the correct protocol, ensuring that they're doing the correct steps with rinsing, scrubbing with detergent, acid, and then a sanitizing step. I hope you've seen is the fact in terms of when it comes to killing your microorganisms and removing biofilms, that CD114, our chlorine dioxide cleaner, is really the best for your protection. Other products we recommended obviously were OxySand being another example. Our foaming chlorinated or non-chlorinated alkaline manual cleaner is the main one for detergent. And then the key is so all these things are very tough to be measurable in terms of how many scours cases that a farm has. So when we want to measure our success with cleaning, you cannot do it based on the amount of cases. And if I go to a farm and they say, well, if I put in this procedure, am I going to have less scours? Truth is, I have no idea. They could have more scours. It doesn't have anything to do with the cleaning if the cleaning is being done right. So the key is you want to measure our success with cleaning is based on using an ATP meter. So actually going in on the surfaces after they've been cleaned to see, are they in fact clean? And if we're doing that, that's really all we can do with it. We can't control the other steps on the farm.
Sorry. All right. Thank you, Ginger and Emma, for the presentation today. We really appreciate it. There's a lot of great information in there. And for those of you who are in the webinar today, there will be a recording that's going to be posted after the webinar. That's going to go up on our socials. So if you haven't already, please make sure you follow us on all of our social platforms so that you can stay updated on our next webinars. And also an email will be going out to the list of today's webinar so that they can also get access to the link to the webinar. So I'm going to give this a few minutes just in case anybody wants to hop in chat and post any questions, and then we'll wrap things up for today, and we'll let everybody enjoy their Friday.
So one question I just received via text and not through the chat room is it better to spray CD114 on surfaces, or is it better to soak it? Emma, what do you think on that? I know what I think, but I'll see what you think.
I'll let you take it, Ginger.
Okay. So I guess where I go with that is that I do see people soaking with it. So the number one thing is the fact you have a very good chemical that's killing bugs, right? So either will work very well. When it comes to, is soaking necessary? I don't think so. I think as long as you're able to get through your surface areas of whatever it is you're washing. Now I know, like spraying on top, if I was spraying a brush, I might say, that might be a little better for soaking because there's a lot of surface area in a brush to be able to kill all the surfaces for where bugs could live. Well, when it comes to more flat, non-porous surfaces, if it's easier, if it's part of your protocol, go ahead and soak, but I think you will use less chemical if you do an effective spray, because either way, you're getting dunked. The product is getting on the surface. It's killing any bugs, removing any biofilm that's there. You're letting it dry before it goes to the next use anyways, so either will work.